Thank you so much. It's amazing to be back here. It's my first time actually speaking at the conference, and I love always coming back, seeing the crowd, seeing the people, engaging in all the discussions with all of you folks. Absolutely amazing. Love that every year. Today, I'm here to talk to you about data contracts, a topic that's very dear to me, that originally invested a lot into the theory crafting around it, but now we actually got a chance to gather some practical experiences with it at HelloFresh, and that's exactly what I want to show you folks today. So I will run you a little bit through the data quality history at HelloFresh, like what was the stages of evolutions that we actually had. And then I will dive deep into the data contracts part by showing you an architecture overview on like how it actually looks like, what we built, and to actually give you what I call a not-so-live demo, where I actually still want to showcase like how that actually looks like when we run it in production. And of course, then close it out with the actual impact that we have already gained through engaging with data contracts and using and running them. Cool. Yeah, I'm Max. I'm the banana-suited gentleman, somebody called me at some point. Associate Director of Data Engineering for the data platform at HelloFresh. And I've been working for the past decade on building data platforms and data management, as well as infrastructure platforms in multiple companies. And as already announced, I'm a huge data mesh advocate, as well as a content creator around the topic. There's a couple of things that you might want to check out afterwards as well. HelloFresh, I think most of you folks know it, a meal kit provider that ships you a lot of food home so that you don't need to go to the supermarket before you can engage in your cooking experience. I've been using it myself even 2 years before I joined the company, so I can definitely recommend that. And just so that you get an idea on the scale that we are actually operating, just like threw out a couple numbers here. But yeah, let's dive right in. Data quality at HelloFresh. When we started the data quality journey at HelloFresh, originally, of course, there was chaos, right? Like you don't have a lot, you have a lot of data, but you have very little quality, and you start to think on how can you actually do something about it. And the first thing that we started was what we call soft data contracts, which is literally Google Docs that people sit together from 2 different teams, where one is providing data to the other, and they list down all the things that they expect, and they list all the guarantees on what they want to give. Kind of nice, because for the first time, people actually start talking to each other and start figuring out what are the dependencies that they have to each other. But also has a couple downsides, because on the one hand side, it's not really enforceable if you have something on paper, and usually those things also get outdated rather quickly, right? So while it is really nice that you get this alignment on the actual expectations, that you actually get the sign-off on the business side of things, again, like the downsides that you cannot really enforce what is written on paper, and them getting outdated quite quickly has like outweighed the benefits by quite a margin. The next thing that we then did is we went towards data quality checks. And this is like now going to the opposite end of the spectrum, being purely technical about it, right? It's on purpose that you cannot really read what's on the slide, so don't worry about that. Just an example check. We are using Soda for data quality checks since almost 3 years by now, I think. We have a great open source library as well that we are engaging with that allows you to essentially define what data quality looks like and define very specific checks for very specific tables or data sets that you have. The biggest problem there was, again, it was more on the other end of the spectrum. It was very technical, so you still needed to do all the things around it, like setting up your own Airflow to actually run the checks, setting up your EMR. We were using Spark on EMR for that. Or we also have a lot of data on Snowflake, so like having those respective environments that you need to integrate with. And then even the whole notification cycle that comes afterwards for instance, sending Slack notifications. Yeah. So now we got the technical enforcement, and we got the monitoring and alerting. And the great thing was that this is really a tool that could be offered to anyone in the organization, be it producer or consumer. They could just start setting up data quality checks on their own. But at the same time, it required engineering knowledge, so it highly limited the amount of people that had access to that. And while we had like huge plans for like rolling this out through the entire organization, we had to realize at some point that the adoption was slower than we had originally expected because there was this level of prerequisites, right? And while you're enabling everybody to set up the checks on their own, that also means you're taking away the alignment piece again because now people just do it for themselves and they stop talking to each other. And that was like, again, the opposite end of the spectrum from being like fully process business driven to fully engineering driven. And that was the part where we actually started moving more towards the middle, towards data contracts. What's a data contract in our area? Well, data contracts kind of start as glorified group of data quality checks, let's say, but you add a bunch of additional things on top of that, right? You add additional meta information about that. You check, for instance, who are the owners of that data set. You check like who are the different stakeholders that are actually consuming it. And then you dive into a bunch of things like version management, when all the checks should actually be executed, how they should be triggered, who are the dependencies, the lineage, and a bunch of things that you can dive into. But the most important part for us, besides having now one template that also collects all this additional meta information, is we have built most of the engineering part into that tool out of the box. So now all you need to do is you need to fill that template, you need to submit that, and then you trigger a bunch of processes that actually take care of the Airflow DAG generation, the actual query execution. You get all the notifications for monitoring and alerting out of the box, so that you don't need to have all that technical knowledge anymore to be able to set up data quality measurements for the data assets that you have. So yeah, now this also has become like the source of alignment, so to say. So data contract is really something that is like signed off by both parties. That is something that we learned from the original process, that you need to really align on the expectations as well as the guarantees that a producer is giving. But then at the same time, it's enforceable because we have the built-in monitoring and alerting, while also now it's becomes implementable with very limited technical skills, right? And that's really good, that's really strong, that's a good vision that we want to get to. The only downside was nobody had done that yet. So it was like kind of hard to even get started, even though we had like some technology partners that we were working with on that. It really meant we were like moving into uncharted territories to try to understand and build something on our own that didn't exist yet at that time. How does that now actually look like? So from the architecture side, the first thing that I want to walk you through is a bit the process, so to say, and then I want to go one level deeper and look at the technical part as well. So yes, the first thing that happens is the data owner creates the data contract. Yes, the data owner is the one that owns the contract as well, because the contract has a one-to-one relation to the asset that is actually covering. Yeah. Now, there's a first set of checks that are actually executed before the data is even published, right? Think of things like schema validation, for instance. That is something that is built in at what we call pre-flight checks, just generally checking the format of the template, making sure like stupid errors are ruled out or you get like quick feedback on those, and prevent breaking changes to happen before they even make it to production, right? Then, once you have executed those, that is a step where the data is actually published. So there, the data is being written, can be on a continuous streaming basis, can be on a batch basis, be it like hourly, daily, weekly, whatever the particular use case needs. But that is really where the data is then actually being written. And then you have the data quality checks. Those are the ones that actually analyze the data after it has been published. And that can, of course, have two different outcomes, right? The first is, well, you find something is wrong. I don't know, one particular column is full of null values, some distributions are totally off, or simply things like the data was late, right? And then you go into alerting. Yeah? You alert the owner. They need to know immediately if something is going wrong. And that is the interesting thing as well. You also notify the stakeholders, right? You make sure that the people that want to use the data further, they also get to know if something is going wrong with the data that they have. And of course, last, if everything goes fine, then you have high quality data. Great. Cool. So that's like more the process view on the whole thing. Let's dive a little bit deeper into how that now actually looks like on the technical side. First thing is the data contract, once it's created, is published to GitHub, right? Like right now, we have all our data contracts in GitHub in a common repository where all the teams are committing their statements into. And while we have a lot of ideas on how we want to integrate this directly with the catalog, for instance, so that you have like better interfaces on how to edit and collaborate on those right now, because we are still somewhat early in the journey, we just focus on what's simple and well proven, which is things live in GitHub, where you have proper version management and proper collaboration tooling to make that happen. Once the contract is published to GitHub, it actually triggers certain actions by reaching out to the data contract service that we have built, which takes care of a bunch of automation. What kind of automation is that actually? Well, it generates the Airflow DAGs for you. It generates Prometheus alerts for you, because those are the main points that you need on the one hand side for the actual execution of the checks that have been defined, as well as for the later on stages for the alerting that you want to send out in case something fails. Once all these steps are generated for you, the next thing is the actual execution of the SLOs that are defined. Right? Those can be executed based on two different measures. They can be executed on the time base, right? If you want to say, okay, this data set is published every day at 6 in the morning, so a check runs at 6 in the morning that checks if the data is there, and if it's not, it throws an alert. If it is there, then everything is going fine, right? What we also have is a mechanism to actually do this based on a signal. We built a dedicated service for that, where you can just like publish an event when, let's say, your data set is available, that then triggers the execution of the contract already at that stage, and it doesn't wait for a particular time. So those are the two modes that we actually have for triggering the execution. And the execution itself, as mentioned before, we are using Soda for the checks. And then they are usually run either on Spark on EMR if the data is on S3, or in Snowflake if we have the data on that side. And then the last part is, of course, if something goes wrong, you have the trigger of the alerts. You have the parts where the Prometheus alerts that I will show you in a second, they can, depending on the priority of the check, either just send a Slack notification somewhere, or even trigger an Ops-Genie call that might call somebody in the middle of the night if the data set is critical enough that it's actually important that somebody immediately takes a look at that. So those are like both mechanisms that we have built in, while at the same time, then we also have the loop to inform the customer again via Slack, so that they have the possibility to see that something is going wrong. So coming to my not-so-live demo, basically what I now want to show you is, like, first things first, how does a data contract look like? It's going to be a lot of information on the screen, but we will digest it one by one so that you can get a good understanding of the different areas that we are covering. And then I will walk you through how the actual execution then looks like. The first thing is the information about who are the parties that are actually having this contract over with each other, right? So you have ownership information, where you have things like the organizational structures that we have, as well as information on how can you reach them, which is usually a Slack channel, which is usually an email. And those are then also the channels that are used for the alerting later on. Yeah, so like those are then the immediately integrated back into the rest of the flow, so that you can inform the people of the things whenever you need to. And you have the same for the stakeholders. And stakeholders can be like a list of teams usually. In this example, it's only one to showcase, but we have some contracts as well where one team publishes certain data that multiple teams depend on. So here it basically gives you a bit of an opportunity to build up the dependency graph and build up like the lineage also in terms of like how the data is further used, so that you as a producer can also understand whom to reach out to, for instance, if you need to make a breaking change for whatever reason, so that you can kick off the conversations early and reach out to the people that you need. The second part is like a bunch of additional metadata that we publish, right? Like you have things like the versioning of the data contract. What we said, we want to prevent breaking changes to go to production. That does not mean that we can stop the development process whenever some breaking change needs to happen, right? What we usually do is we have incremental versions, and then it means like a breaking version is being published in parallel to the previous version, and then the consumers have some time to actually migrate to the new version before you entirely shut down the previous one. So that's one of the things here. But then, of course, you have also some additional information like in there, like, well, what data asset are we actually talking about, where to find it, some general descriptions, what are like if that is supposed to be executed on a particular time. So like all this information you have in terms of the additional meta information in there. The most important part, though, are, of course, the SLOs, right? And we have like multiple things in here where we are still somewhat close to the original soda checks that we are working with, but we are also actively working on simplifying this more and more and have like more, let's say, templates for standard checks, right? What you see here on the screen right now is, for instance, a row count check that says, okay, a particular, for this particular data set, the row count should be above, what is it, 100,000. And if that is not the case, then that will be treated as a P4 alert, so that will actually trigger something. Another example is a freshness check, right, where you just define, okay, this is the time that was originally introduced earlier, and that gives you then an example of what is happening when the time is breaching, what is supposed to be executed. One interesting thing here is we also put in a particular statement where the logic of actually executing that is a bit more complicated, but we're just linking a particular SQL snippet that is sitting outside somewhere so that we can still simplify the readability of the contract itself. And then we have like a SQL statement like this, which is basically like templated based on the input that we get from the check itself, which is then the one that is actually executed based on the parameters that you have provided. Once the contract is executed, there's multiple things that we can show, right? This is actually then how it looks like on the Airflow side. You actually see in the red box, that is the part that is actually executing the SLO. So we have like the different operators in terms of like creating the job, running the job, shutting down the environment again, so that you can really see like, okay, that's like what is supposed to be run to actually execute those checks. And then on the right-hand side, you have the part of actually like sending the notifications. So there's like two different tasks that we have, both on the one hand side to notify the owner in case something is going wrong, as well as to notify the consumer through the different channels on that side. How does it actually work from the alerting perspective? As mentioned before, we are using Prometheus. This is like one sample for one particular data contract that we have. So we have like something like 10, 12 checks defined. And that's like, of course, it looks nice and easy when everything is green. You have a lot of the extra information in there as well in terms of like what you are actually looking at. That's usually the information that is pre-populated based on the information that we had previously seen. But it can also give you some links already in terms of description or follow-ups and where to go and what to follow up on if that alert actually fails. If that alert actually fails, well, the whole thing is actually quite simple because you define a Prometheus alert, and if it's 1, then everything is fine. And if it's 0, then it fires an alert, right? So you just define a certain threshold on the quality check. In this particular case, we have the metric value, which is like something around 158,000, which is greater than the defined threshold that we have. So everything is good on this particular side. So the alert value goes to 1, and no alert is fired. So everything is good on that particular side. If an alert is fired, that is more or less how it can look like. So that is like a Slack notification that we actually had there for one particular table where basically the freshness check was breached. The data set was published too late. So we executed, we realized data isn't there, and then the alert was sent to Slack. And that is where, for this particular team, they understood. And there was even a very nice follow-up on this particular conversation where then team members from the owning and the consuming team started to engaging into a discussion and giving them pointers in terms of, hey, okay, I'm checking this part now. And then they actually had a conversation under this alert where they were actually solving the issue so that they could proceed with the production side of things as well. So that was really cool. Yes. Now that we walked through like all the technical part on the data contract side, of course, also want to talk a little bit about what was the actual impact of those, right? The first thing is data quality made simple. So we are really getting to the point that there is no need for the deep technical knowledge as it was before, because we are taking away a lot of this like infrastructure-related parts from the users by encapsulating this within the platform. And with that, not only do you get like the nice framework for setting up all the checks that you want to execute, but you also get the monitoring and alerting out of the box because that's directly integrated with the platform. At the same time, we now have clear definitions of expectations and guarantees. Yeah, so from both sides, the consumers and the producers, we have what is the consumer actually expecting from me that goes into the negotiations for actually creating the contract. But then the contract itself also states what are the guarantees that will be given, and that can be things like freshness, completeness, distribution SLAs that are following up exactly on that part. And last but not least, easy usability. So all the information that we have is also visible in the catalog to actually ensure that we have exactly what is needed, all the information, also in terms of the check executions over time, so they are visible to the users, so that they can actually build up trust for the particular data sets and have the alignments on the contract itself. Thank you so much.